So welcome everybody to the introduction to using Argo CD with the Akuity platform webinar slash workshop. Today we're going to go through some high-level theory on GitOps and continuous delivery, and then talk about where Argo CD plays into that. And then we'll take that into practice and do a lab with using Argo CD to deploy Helm charts to a cluster in a GitOps fashion. I recommend taking a moment to go and spin up your Kubernetes cluster, as the practical component of this requires that you have a Kubernetes cluster available to you. I recommend a dedicated Kubernetes cluster because we're going to be installing stuff into it and stuff at the cluster level, like cluster access, cluster role bindings and service accounts and so on. So that can just be a local kind cluster. I'm going to demonstrate spinning up a kind cluster during the practical component, but you could also use K3s or Docker Desktops cluster, or go spin something up on something like DigitalOcean. It's all the same as long as you've got a Kubernetes cluster with internet access. So with that out of the way, I recommend we're gonna go through some of the theory here. So the idea here is that we're gonna talk about continuous delivery as a whole, GitOps as a whole, and then Argo CD, and then we're going to talk about how kind of they all play together and what their roles are in the software development lifecycle. So delivering your applications to a Kubernetes environment, though these GitOps practices are more widely applicable than just Kubernetes. For the context of this webinar, we're going to be talking Argo CD and Kubernetes specifically. So welcome everybody. I'm going to start off just by discussing who I am and why you should listen to anything I have to say. So my background is as a platform engineer. I'm passionate about DevOps practices. I worked as your average platform engineer running Argo CD for a large website here in Canada where I'm based. And now I'm over with the Argo project and with Akuity as a developer advocate, talking about all the lessons that I learned running Argo CD in production, and also some of the cool stuff that's coming out of Akuity. So for the workshop topics, we're going to start with an introduction to CD and GitOps, talk about some Argo CD core concepts, and then these last two topics are the practical components, where we're going to go ahead and implement some of what we've talked about here. So the first question here is, what is continuous delivery? And the answer seems to depend on who you ask. So if we were to ask Microsoft, continuous delivery is the process of automating build, test, configuration, and deployment from a build to a production environment. It makes sense. If we were to ask AWS, continuous delivery is a software development practice where code changes are automatically prepared for a release to production. Okay, so now we're getting that automated part and for release to production. That's maybe only one of the steps, in my opinion. Continuous delivery lets development teams automate the process that moves software through the software development lifecycle. So that I like this more from IBM because it starts to incorporate the entire software development lifecycle. It's not just about the release to production, but it's important to consider the lower environments as well. If we were to ask Red Hat, who they're a major contributor to the Argo CD project, so they've got a hand in this as well. Continuous delivery is a software development practice that uses automation to speed the release of new code. So this is great. Now we're talking about velocity and how quickly we can release new code and release changes and produce value to our customers through continuous delivery practices, which starts to incorporate kind of business value of implementing something like this. This is probably my favorite explanation, because it's coming from, let's call it the authoritative source, continuousdelivery.com, which is maintained by Jez Humble. Continuous delivery is the ability to get changes of all types, including new features, configuration changes, bug fixes, experiments, into production or the hands of users safely and quickly in a sustainable way. Now, this is probably the most holistic answer for what is continuous delivery, as it's not specific to any one technology. It's not specific to any one type of value stream. We're talking any features or configurations or any changes to software that you maintain, getting that into the hands of the people that would value from those changes as safely and quickly as possible, which comes back to that business value of, if you can out experiment the competition using something like continuous delivery, you can provide value faster and better. And we'll take it back a moment. If we were to ask ChatGPT, continuous delivery is software development practice that aims to release software changes frequently and reliably. This is probably the most concise answer, but it also has the least amount of depth to it. In my opinion, continuous delivery is the software development practice of automating the release process from once the build is complete to running in production. So it's probably good to talk about what CD is not in this context. Continuous delivery is not continuous integration. You'll probably likely see those two terms squished together in every piece of marketing material ever, CI/CD. Well, it's important to understand the distinction for that, so that you can kind of frame the practices that we're talking about today. Continuous delivery, or more specific, continuous integration, is regularly merging code into your main branch or your trunk of the repo. So it does not involve the actual build process for that software. It's about that as you regularly merge code, there should be automated testing and packaging. But taking that packaged software and putting it into an environment, that's the continuous delivery side. The reality here is that the lines are kind of blurry between CI and CD, so it's fair that they get lumped together. Like, for example, if you've got a CI process that builds a Docker image, and then you do your testing on that Docker image or using that Docker image, it's kind of there's CD, and then you're coming back to CI to do the testing of that package. But if you're testing that Docker image in an environment, then that comes back to continuous delivery. And like similar, like if you have an NPM module, is that continuous delivery of deploying that NPM module to the registry? It depends. The important point here is that continuous delivery is focused on taking your already packaged and ideally tested piece of software and implementing it into an environment in an automated fashion, and ideally all the way through to production. Now, you might have heard of a different CD out there called continuous deployment. So we've got our continuous delivery, what we're focusing on today, and we've got continuous deployment. The other CD, continuous deployment, is generally represents an entire automated CI/CD pipeline. So if you've got everything from checking in your code to testing that, to packaging it, to delivering it to a lower environment, promoting it to the next environment automatically using like health checks and maybe something like Argo rollouts to establish if that copy of the software is ready to get promoted to the next environment, then you could consider that continuous deployment if the entire process is automated, including rollbacks. Today, we're going to be talking just about continuous delivery, which is the taking your packaged software and getting it into an environment. So that's CD. So in this context, what is GitOps? Well, in this case, it doesn't depend on who you ask, because there is an authoritative source for the answer to this question now, which is opengitops.dev. This is a CNCF sandbox project that is working to establish vendor neutral and tooling neutral guidelines and principles for GitOps that establish how to implement these practices and what the practices are, no matter if you're using Git or SVN or if you're using Kubernetes or VMs. It still should ultimately all be GitOps when following the principles laid out by this project. As it stands right now, version 1.0.0 of Open GitOps, there are 4 principles to follow. The first is declarative desired state. So this is, you have all of the configuration and components for your state of an environment declaratively stated. I guess maybe a better way to put that is that you have it encapsulated in one copy of your entire desired state. And then that leads into that desired state should be immutable. So you have all of your configuration for your state, and then you have a specific point in time, an immutable copy of that desired state in whatever your state store is. So in the context of GitOps and in general, it would be Git. It would be something like GitHub or GitLab. That's where you would put your desired state, and that gives you both the declarative part and the immutability of it, because every change to something in Git, you get a new commit hash, and therefore you can tell the difference between a previous version of the desired state and the new version. And then when you're using something like Kubernetes, the declarative desired state is all of the manifests that represent the resources deployed into Kubernetes. And then, so you've got your desired state declaratively put into Git, so it's immutable. And then you want continuous reconciliation of that desired state into your live state, into your cluster. So you would take, in this case, Argo CD is going to do the continuous reconciliation. So it'll look at your Git repo that has all of your manifests that describe the desired state, and ensures that that desired state is represented as the live state within the cluster by continuously reconciling that. So as a change is put into your desired state in Git, Argo CD will pick that up and make the appropriate changes within the Kubernetes cluster to update the live state of the cluster to match the desired state. Obviously, with something like Argo CD, there's a lot of options for how you configure that, and the exact nuances of how that deployment works, since it's a fairly unopinionated tool. But in this context, what matters most is that it's a continuous reconciliation, that it's automatically checking that there is a difference, and ideally automatically updating the desired state. And then finally, the last principle here is that everything or operations are done through declaration. So that means I, as an operator, shouldn't be going into the cluster and making a change directly. I shouldn't be using kubectl or Helm to make my changes in the cluster. Instead, everything should be going through that declarative desired state in Git. So I want to make a change to what version of a Helm chart I'm deploying. I wouldn't use the Helm command line for that. I would update that in my Git repo, and then have Argo CD go and pull that into the cluster. And so, speaking of pulling into the cluster versus pushing, it's good to take a step back here and discuss what happens without GitOps. So without GitOps, you're effectively operating on the push model, which is as a developer goes and writes a change to a piece of software, that might trigger a run in your CI pipeline, which then builds the image, maybe does tests or whatever, pushes that image to the container registry, and then as a part of that CI pipeline, goes and does like a kubectl apply to the cluster, and it's pushing that change, that new container image, into the cluster essentially. Or maybe it's running, your Helm upgrade command to go upgrade a chart, but it's interacting directly with the cluster from the CI workflow. So you make a change to your software, it builds it, the new container image is ready, and then it pushes that into the cluster. With GitOps, it changes it to a pull-based model where instead of at the end of your CI pipeline, once your build is ready, you go and you do something like kubectl apply or Helm install and push that into the cluster. You now have your software agent, in this example, Argo CD, running in the cluster, and that goes and it pulls that configuration down from a config repo. So you like in the previous example, you've got your app code repo, which stores your application source code, and then that automatically generates an image and then pushes it into Kubernetes. With GitOps, you would have a similar process all the way up until the image is deployed into your container registry. And then you would have a config change, a dedicated configuration repo, which is that desired declarative state from the GitOps principles that we saw earlier, that describes how to deploy into the cluster. Then that agent running in the cluster would go and look at that config repo and determine what to update in the cluster itself. So that manages that lifecycle instead of your CI pipelining when it runs, your CI pipeline pushing that change into the repo. It could go and push that change into the config repo, update the desired declarative state, but your agent running within the cluster is going to go and pull that down. And the benefit of something like this is that you don't need to have cluster credentials or your clusters even exposed for your CI pipelines to have direct access to them. So to push that container into the cluster. So if you've got like GitHub Actions, for example, that's generally hosted on GitHub's infrastructure. So if you want GitHub Actions to be able to go and push changes into your cluster, you have to expose your cluster to GitHub Actions, which is either done with a bunch of overhead through IP whitelisting and maintaining those, or you expose your cluster to the entire internet to simplify it, but then you have the security concern that your security teams might not be super happy about. So the option here is to instead have the agent running within the cluster. That agent has all the necessary permissions to be able to make changes within that cluster. Instead of your GitHub Actions pipeline having cluster credentials that can make changes, it's running within the cluster. It's all self-contained. And then all it needs is permissions to get to the repo to read from the declarative state. It doesn't have to have write access or anything. And then from the declarative state, it only needs write access within the cluster to go and make that change. Just a brief tangent here to answer a question in the chat. Helm file is not officially supported by Argo CD as like a built-in config management tool that it supports, but there are support for config management plugins that allow you to implement additional tooling that can be used by Argo CD. And I think if you go and you do a search for Argo CD Helm file, you should find an example of a config management plugin that people are already using to implement Helm file, because it's you're not the first person to ask for this, but it hasn't been introduced as a first party tool, but it can certainly be done with Argo CD using config management plugins. Okay, so brief tangent aside, the push versus pull model, with that in mind, so what problems is GitOps solving here? Well, it's solving the control, your access to the cluster. Instead of requiring all of your application developers to have direct access to Kubernetes, you can Instead, give them access to the configuration repo, set up all of your checks and balances through pull requests and code ownership and all of the features that are provided by your Git provider, either GitHub or GitLab, and use that to interact with the state of the cluster instead of people going and making their changes directly. And then similarly to how PRs are great for adding control, they're also great for adding collaboration. So when somebody wants to go and propose a change to the desired state of the cluster, they want to go and deploy their new version of their application, or they want to add a new service to the cluster or anything like that, they can do that through a PR. And that allows other people, maybe you've got a subject matter expert on Kubernetes that would like to go and review the manifests before they're applied applied into the cluster. They can have their opportunity to go and do a review of that PR, or you can make sure that there's at least some checks and balances for somebody going and saying, like, I've looked at these manifests, I think they're good. Send them through, versus somebody just having direct access and choosing to deploy whenever they want. And then that leads into the compliance needs, in that if everybody is making changes directly to the cluster, there's no clear audit log of state changes to that cluster. Sure, you could go through and pull it from Kubernetes events, but anybody that's tried to do that would know that they're fairly noisy and it's hard to filter down into like what actually matters. And you'd have to have a separate tool to go and maintain those Kubernetes events because they get purged from the cluster on a fairly regular basis. Instead, you get all the benefits of Git, which you're probably already using to satisfy some of your compliance needs for your source code, your application code, but you can now use those same processes for your compliance needs on configuration and state changes within your environment. You can take that Git log and show exactly what changed and why and when that happened. And then through that clear audit log of state changes, it enables rollbacks in a fairly easy manner, and that when you make a change, you know immediately what the previous state of that cluster was. So if the change you make breaks something, you can go and do simply like a git revert. Maybe you have to go through a pull request or something, but once that's on the branch that Argo CD is watching, it can go and roll back your changes to that previous version of the desired state of the cluster, instead of, back when I was doing, releases and they had me as the operator do it for the developers. If there's like a config map change or something, I need to go and make a copy of that config map. Maybe I make a copy locally, like I go and, do get config map YAML and pipe it to some config map.backup file. If I forget to do that and I need to go and roll back that config map, we have to either go figure out what it was on the last release, or go ask the right person to tell us what the right value is. With GitOps, I can just go and revert that commit that made that change to that config map and get that previous state for it and roll it back easily. And then ultimately that leads into disaster recovery, in that if you've got the desired state for your environment declaratively stored in Git, then to bootstrap a cluster is fairly simple. You can go and maybe do the initial infrastructure through something like Terraform. You get your cluster, you do one command locally, or have Terraform deploy Argo CD into that cluster. And then from there, Argo CD can go and look at your configuration repo in Git and pull everything down into that cluster, updating it to the desired state from before, let's say you lost that cluster and you had, causing you to do this disaster recovery. And so from there, we can talk a bit more about Argo CD and how it is related to these CD and GitOps practices. So for Argo CD core concepts, there's the application resource, which essentially represents how you're going to deploy what into the cluster, and we'll get into more details on that in a moment. Your config management tools, what you're using to deploy into the cluster or define your set of manifests, the application sync and health and app projects. So let's go. Do we go through each one? Okay. So during the workshop, we'll be playing with each of these core concepts in practice to go and implement Argo CD into a Kubernetes environment with GitHub backing it. And so we're going to test syncing an application, which is taking that declarative state and getting it into the cluster. And your config management tools, in this case, we're going to be using Helm, but that could also be something like Customize, or it could be raw manifests, or it could be a config management plugin that describes any other number of binaries to run during that process of rendering the manifests. And then because we've got this resource, the application defining what gets deployed where, we can also introduce this concept of health for that application to say that what should be deployed isn't currently deployed, degrading the health of that application or what have you. Again, we'll demonstrate this during the workshop. And then ultimately there's concepts like app projects that provide isolation between sets of applications or multiple teams. So the common practice is to have an app project per team, and then that describes what that team is allowed to deploy and to where. And so we just got a quick question here in the Q&A. How can you create applications with Terraform and Argo CD? If you create applications like applications inside applications, if you use your Git repo to create. Yeah, so the conversation of Argo CD and where it fits into Terraform. Yeah, I think it might be a hard question to answer right here, but the common practice is to have Terraform stand up the Kubernetes cluster. And then depending on how your organization works, you could either have someone manually do that initial bootstrapping of Argo CD, which would be to install Argo CD. And then if you're using the app of apps pattern, have Argo CD effectively managing itself after that initial bootstrapping, which we will get into app of apps a bit later in the practical component. Yeah, it's a great question, and I'd be happy to talk more about bootstrapping clusters with Argo CD after this. If you want to reach out to us either on the CNCF Slack or hit me up on Twitter. Yeah, I'd be happy to have a deeper discussion about this. But for the sake of the webinar, we're going to jump into the practical component. So speaking of which, we're going to be using the Akuity platform for the practical component today. So if you're used to the open source architecture, you'll be familiar that typically you've got a cluster running Argo CD, and then to manage multiple clusters outside of that, you would need to go and expose those clusters to the one that's running Argo CD, and then Argo CD connects directly to each of the managed clusters. This architecture puts a lot of pressure on the central control plane that's running Argo CD, since all of the actual processing stays or is within that control plane as you scale out more clusters. And then also all of the Kubernetes events that's happening within each managed cluster needs to get streamed back to the control plane, consuming generally a significant amount of bandwidth depending on how many applications and clusters you have. And then that needs to be processed in the control plane, only for that to get sent back out to make changes in that cluster depending on those events. So with the Akuity platform, Argo CD has been re-architectured so that in each managed cluster, you're running an agent that contains all of the components necessary to manage the processing for that cluster. And then Argo CD is effectively running on the Akuity platform, which acts as a control plane for Argo CD. So all of the metadata about applications and app projects and application sets, that's all stored on the Akuity platform and is managed along with Argo. And then you have your agent deployed into each managed cluster that does the resource generation and management for that cluster, meaning that you don't have to stream all of the events from each managed cluster back to the control plane in order to do all of that processing, which saves on network bandwidth. And then you also have the agent lives within each cluster and has the credentials necessary to make all of the appropriate changes. So you don't need cluster credentials. Like if we look back at the open source architecture, in this one, you need cluster credentials for every managed cluster stored centrally on the control plane, which your security team might have some questions about in terms of blast radius, since if the control plane is compromised, so are all of the cluster credentials. With the Akuity platform, the agent contains all of the access required to make changes within that cluster, and it stays within that cluster. So the control plane ultimately doesn't have credentials to each of the managed clusters. So just to recap here, the managed clusters are more isolated in that they contain the credentials necessary within the cluster instead of storing them all in the control plane. All of the processing stays within that managed cluster, so you're not sending all of the Kubernetes events back to the control plane. And then it also scales as you add more clusters, because the processing for each connected managed cluster stays within that cluster instead of adding more and more load to the control plane. So with that explanation out of the way, we are going to jump into the practical component of the webinar. So to start off with here, there's a couple prerequisites to this. So I'm assuming that everybody already has a GitHub account, which is required because we're going to be using that to answer the Q&A question here. So the control plane talks to the managed cluster through the agent that's deployed into it. So the agent within the cluster contains the credentials to make changes to the cluster that it's in through the service account that it's deployed with. And then it has credentials that allow it to talk back to the control plane, but that's only for streaming the metadata required to power the UI. There's no credentials on the central control plane that would provide you access to the each connected managed cluster. Let me know if that doesn't quite answer your question. I'm happy to field more of them if that doesn't quite do it for you. Great, thank you. So I assume everybody has a GitHub account. You'll be using this to create the repo that's going to store the environment configuration, and it's also going to be used for logging into the Akuity platform, though you could log in with something other than GitHub, but for the sake of this webinar, it's simplified if you use GitHub for it. I assume you already have kubectl installed, that you already have a Kubernetes cluster with cluster admin access available to you, since we're going to be creating namespaces and cluster roles. For this, I'm going to demonstrate creating a cluster with Kind, but you could easily create one with K3s or Docker Desktop or spin one up on DigitalOcean. Just no matter what, you're going to need a Kubernetes cluster available to you. So to start off with, we're going to create a repository from an existing template. So I'll go and I'll paste the link here in the chat. So if everybody could go to that link that's in the chat here, and I'll go ahead and do it up here as well. So from this intro Argo CD tutorial template, on GitHub, and the link is in chat there. We're going to click use this template, and we're going to create a new repository from this template. I recommend setting the repository name to intro Argo CD tutorial. And then we're going to make sure that this is a public repo. So once again, use that link that's in the chat there, create repository from the template, name that repository intro Argo CD tutorial, and then we're going to click create repository from template. And so this will take a quick moment to generate. This template has a couple of placeholder values in it that we need to update. So if we go, fun tip here for anybody that's following along. If you either change .com to .dev or simply hit the period key while on your GitHub repository, it will open up VS Code in the browser, and then you can go and make changes from your browser to the repo, just like you're editing in VS Code locally. So I'm going to be using that throughout this tutorial to avoid copying or cloning the repo locally and having to open it up in VS Code, because essentially everything you're doing today can be done through the browser, with the exception of standing up Kubernetes, unless you plan on using something like DigitalOcean to do it. Yeah, you're welcome, Naveen. I was amazed the first time that I learned about this tip. It has saved me a lot of time, especially doing things like this webinar and workshops. Okay, so I'm assuming everybody at this point has created their GitHub repository, and that they've either cloned it or opened up VS Code in their browser to go and make it available for editing. So I'll zoom in a bit here. What we have to do is that there's some placeholder text within the repo that we need to update. So I'm going to demonstrate doing this with VS Code, but search and replace these strings with whatever tool fits best. So the first string that we want to replace is username. And we're going to replace that with our GitHub username. So in my case, I'm going to be replacing that with Mori Tech. And you'll be replacing that in the app of apps file, the apps/guestbook.yaml and apps/portal.yaml file. Search and replace username in the pointed brackets and replace that with your GitHub username. Effectively, what we're doing with that step is we're updating the repo URL from the template URL to the new repo URL now that you've created a copy of that template. And then the other one we have to update is the environment string. So you'll see environment in pointed brackets. I'm going to be using staging as my environment name, but technically you can use whatever you want here. The idea is that you just need to be consistent. Everywhere that we use this environment placeholder, you want to use the same value for it everywhere. So to simplify it, if you're following along, I suggest using staging. That'll make it consistent for the later steps with what I'm doing. So if we go look at the changes we've made here, we're updating username to our GitHub username, and we're updating environment to staging. And we'll go and we'll commit that to our repo, update placeholders, and we'll commit and push that. And then for those that are using VS Code in the browser, if you want to get back to your repo, you can click GitHub in the bottom left and then click go to repository. And just to give an example, so your commit with updating the placeholder text should look something like this, where you've updated the three files: app of apps, apps guestbook, and apps portal, replacing your username text and your environment text. Now that we've done that and we've push those changes to the main branch in the repo. We're going to spin up a Kubernetes cluster. So for my example, which if I share my VS Code window for a moment, in my example, we're going to be using kind. So it's frankly, there's not much to show here. It's if you've got kind already installed and you've got your Docker daemon already running. So if you've got Docker desktop open, it should be as simple as kind create cluster. And that's going to go and pull the node image, and then it's going to prepare the nodes and start them up. But frankly, you can use any Kubernetes cluster you want as long as it's got internet access. And so with that, I've got my Kubernetes cluster. I'll just double check by getting the nodes. And we can see that I am in fact pointed to my kind cluster that I just created 12 seconds ago. And so we'll go back to GitHub here. Yeah, and shout out to your favorite Kubernetes local development tool in the chat. I'm personally in the kind family. I don't know. There's something just so pleasant about the kind experience and the kind cluster manifest approach for like defining everything you want to do with your cluster in one manifest. I really love. I fell in love with that early because you can define like multiple nodes and everything. Daniel is a huge K3D fan. I don't get it. Doesn't seem that cool to me. But anyways, a bit of a tangent there. So at this point, everybody should have their GitHub repo that they've cloned from the template, updated the placeholder text within it, and then they've got their Kubernetes cluster up and running. Now we need to launch an Argo CD instance on the Akuity platform. So if you go to akuity.io and click the free trial button, that'll take you to the sign up page. For the sake of the webinar here, I'm going to be doing continue with GitHub. Since I'm assuming everybody has a GitHub account, that's kind of a prerequisite. The first time you log in here, you'll have to create an organization. So you can click new organization. And I should throw that link in the chat here. You're going to want to go to akuity.io to go and click free trial. And then that'll take you to the sign up page, continue with GitHub. And then you should end up here on the Akuity platform being prompted to create a new organization. After you've signed in, go and create your new organization. You can name it after your GitHub username. That's one of the simplest methods for choosing an organization name, but really any arbitrary value will work. Once you've got your organization created, we could go and create an Argo CD instance. So from the left-hand side here, click Argo CD, and then in the top right, you'll see create. So if you click create, we'll create a new Argo CD instance. We'll give it the name cluster manager. That's what I like using for this workshop. But again, this is one of those cases where the value is arbitrary. So choose what you like, but I'll be naming it cluster manager. And then I'll just click create. We'll use the default version, which is the latest supported V6 version, which is V6 4 right now. Your cluster will start progressing, or your Argo CD instance will start progressing and spinning up on the Akuity platform. So while it does that, we're going to go and change a couple settings from default about this instance. So from your Argo CD instance, click settings. Under features, go to declarative management, and then click enable and click save. So we'll demonstrate this later in the practical component. But what declarative management does is that it exposes the in-cluster destination to in your Argo CD instance on the Akuity platform. So if you're used to the open source architecture, in-cluster is always available by default because that's where you've deployed Argo CD to, and it assumes that you're going to want to deploy resources into that cluster. When using the the Akuity platform, the Argo CD instance, you don't have a full cluster available. Instead, it's hosting all of the Argo CD components for you and assuming that you're connecting managed clusters or connecting clusters to Argo CD to go and deploy your resources to. So that way you don't have to deploy Argo CD into each of your clusters. But when you're doing something like app of apps or application sets, you still want to deploy Argo CD metadata to the in-cluster destination. So that's where it comes in handy here. And if that's hard to picture, just based on my explanation of it, don't worry. We're going to demonstrate it in the later portion of the workshop. So that kind of tangent aside, settings, declarative management, click enabled, click save. From there, we're going to enable the admin user, and we're going to be using that to log in today. So if you go to security and access and you go to system accounts, you can click the toggle for the admin user and then click confirm, and that will enable the admin user on your Argo CD instance. And then for the admin account, click set password and click regenerate password, which will generate the admin user's password for you and then make it available to you by copying it. So after clicking regenerate password, click copy, and then you can close that pane. And if you scroll up to the top of the page, you'll see the URL for your Argo CD instance. And if you click that, it'll bring you to the Argo CD UI that you're probably all familiar with. If you're interested in Argo CD, you've probably seen this page before. And so with that password that you just copied, enter the username admin and paste that password. And then if you click sign in, you'll be presented with the all familiar Argo CD UI. So I'll just take a moment to ask, yeah, just like Daniel's asking, is anybody stuck on any of those steps? I know we kind of went through a lot there, but the expectation at this point should be that you have your GitHub repo from the template, you've got your Kubernetes cluster, and you've spun up your Argo CD instance on the Akuity platform and have logged into it with the admin user. So I can pause here for just a moment to see if we've got any questions that come in. Otherwise, as Daniel's posted in the chat here, all of the steps for this practical component are listed and written out in our documentation. This is a tutorial that we provide to anybody that wants to learn how to use Argo CD for the first time. It's kind of a catered experience. And for those that are jumping to the docs in the tutorial, we're on step 3.3, or we just completed step 3.3, moving on to step 3.4. And since we've got no questions coming in, I'll continue on with the tutorial here. So you've logged into Argo CD, you've got a Kubernetes cluster, and you've got your GitOps repo. The only thing missing here is now we need to connect the Argo CD instance on the Akuity platform to your Kubernetes cluster. So from the Argo CD instance on the Akuity platform, if you go to clusters and you click connect a cluster, you can enter your cluster name here, and you'll use your environment name as the cluster name here. And so if you remember when I updated my GitOps repo, I replaced environment with staging. So I'm going to use that same value here. This is a crucial step because we updated the manifests to say that the destination name is staging. And when we enter the cluster name here, that's going to become the destination name that's available within Argo CD. So that's going to be, since I'm using staging in the manifest, I need to call my connected cluster here staging as well, because that's going to create the correct destination name available in Argo CD. So when I enter staging here for the cluster name and then click connect cluster, that'll go and provision an agent and present to me a one-click install or one command install for deploying the agent manifest to my cluster. So I'm going to click copy to clipboard here and then done. And then we'll go back to VS Code here where I've got my Kubernetes cluster, which if I do k get nodes to make sure I'm connected to the right cluster, because once I run this command, it's going to automatically deploy the agent. So it's important to stop here for a moment and check that you're connected to the correct cluster, which in my case, I am. I'm connected to kind control plane. So if I paste and run that command, it'll deploy all of the resources required for the Akuity agent into the cluster, and that's deploying to the Akuity namespace. So if we do k get pods and we check the Akuity namespace, you'll see all of the relevant workloads for the agent. And they're starting to initialize, they're starting to run. So we'll go back to the Akuity platform here, and you can see that the cluster agent is now progressing, and we're just waiting on a couple workloads to start up. And that should happen any moment here. So I'll stop to answer a quick Q&A. I'd like to know how I can build Argo CD Helm application inside an Argo CD application. I'm going to ask the same in your Slack channel. Thanks. Yeah, we're going to demonstrate deploying an Argo CD, or we're going to go and demonstrate deploying a Helm chart with an Argo CD application. I think that's the question that's being asked here, is how to deploy Helm with an Argo CD application. Let me know if I'm getting that wrong, but we are going to demonstrate that. We're going to take a Helm chart from that repo we cloned and deploy it into the cluster using Argo CD. Yeah, great question, Naveen. So the Akuity platform does have a self-hosted offering available, or an on-premise offering available. So we've got the standard SaaS offering, the Akuity platform, and then there's also an on-premise offering available. And then for automatic onboarding of a new cluster, we have both the Akuity CLI available that could do the agent manifest generation for you, or there's also the Terraform provider, which would allow you to, after creating your cluster with Terraform, provide those cluster credentials to the Akuity Argo CD agent resource, and then that would deploy those manifests into that cluster based on those credentials. I think Daniel is going to be providing a written version of that answer and possibly some links in the chat there. So coming back from those questions, we can see that the cluster agent is now connected, up and running, and reporting back to the Akuity platform. So we now have the staging cluster connected to our Argo CD instance. And if I go and I look in Argo CD here and I look at clusters, we can see that's reflected here as the staging destination is now available. So with that done, we can go and deploy something into our cluster using Argo CD now. So for this example, we go back to our GitOps repo. So our intro to Argo CD tutorial repo, and In the apps folder, you'll see guestbook.yaml. We'll take the contents of guestbook.yaml and we'll go over to the Argo CD UI. We'll click New App. We'll click Edit as YAML, and then we'll paste the contents of the guestbook.yaml file from our repo. So just to reiterate here, from our GitOps repo, our intro Argo CD tutorial repo, from the apps folder, go to guestbook.yaml, copy the contents of this, and then go back to the Argo CD UI, click New App, Edit as YAML, and then overwrite the template YAML that's there with the contents of guestbook.yaml. And so what this is going to do is it's saying that the source of this application is the repository that we copied the file from, the your GitHub username / intro Argo CD tutorial. And from that repo in the guestbook path on the target revision, deploy the manifest from that guestbook path to the staging cluster in the guestbook namespace. So the guestbook namespace on the staging cluster, deploy the contents from the guestbook path in our repo URL. And then we've added a sync option here to automatically create the namespace. So it's automatically going to create this guestbook namespace in the staging cluster when we create this application. If we look back at our repo here, just to explain what it's going to deploy, that guestbook path within our repo points to a Helm chart in Git. And then that's going to go and deploy a deployment and a service based on what's rendered from that Helm chart. So back on Argo CD here, I'll click Save, which will translate the YAML we pasted into the fields in the wizard here. And then we'll click Create. That'll close this pane and create a new guestbook card on the applications page. And then if we click into this, the app health is currently missing because none of the resources have been created before. And we can see that it's currently out of sync, meaning that the declarative desired state in Git is out of sync with the live state that's in the cluster. In this case, the desired state wants to create a service and a deployment, but in the cluster, these resources don't currently exist. So to take a deeper look at what it wants to actually create beyond just these resources in the resource tree here, if you click appdiff at the top of the application page, and then I recommend using compact diff and inline diff because it makes it a lot simpler to see what's changing. We'll see that it wants to create this service manifest, and you can see everything about the resource it wants to create because that's the manifest that was rendered from the Helm chart. So it's not just the template, but it's the template with it populated with the values from that chart. And same thing with the guestbook deployment. This is the exact manifest that it wants to go and deploy into the clusters. Because it currently doesn't exist, the appdiff is showing the entire manifest of the resources to create, because that's the entire manifest is what's different from the live state. So with that in mind, now that we know what it's going to deploy into the cluster, you can click sync and then synchronize, and that'll go and tell Argo CD to reconcile the declarative desired state with the live state. So go and actually deploy the service and the deployment into the cluster, which you can see after creating the deployment, it generated a replica set, and then that replica set is deploying a pod. So these top level resources are what's generated directly from the source of the application. And that source of the application, again, is coming from our GitOps repo, from the Helm chart in the guestbook path within our repo. That Helm chart generates these top level resources, And then the resource tree visualizes the resources that are generated from those. So we can see that our deployment creates a replica set, creates a pod. So this is really fantastic for application developers that are new to Argo CD or new to Kubernetes, I should say, and don't have a deep understanding of all of the resources and how they connect and what their relationship is. The Argo CD UI visualizes that for them to say that, our guestbook application creates a service and a deployment, and then that generates these resources as well. And you can see that these resources have like a health indicator on them saying that these are healthy. So if there was a problem, say a pod couldn't spin up or something, that would be visualized for the developer that's interacting with Kubernetes through Argo CD. So it really simplifies that experience and allows them to focus on what matters, which is the application delivery, instead of learning how to use kubectl and read that command line output. So at this point, we should have a guestbook application running in Argo CD, deploying to our staging cluster, which for sake of demonstration here, if we go back to my cluster, we should see pods in the guestbook namespace, which we do. So that's that guestbook pod is what was created by Argo CD, by that guestbook application in Argo CD. So just heading back here. So that's great. We have our application deployed. So let's demonstrate what it's like when I have a new release of my application or of my guestbook to deploy into Kubernetes when we're using GitOps and Argo CD. So to demonstrate this, we'll go to our GitOps repo, and from the guestbook folder containing the Helm chart, you'll go to values.yaml. So that's guestbook/values.yaml. And we're going to update the image tag from 010 to 020. So this would be demonstrating what it's like to, I've created a new feature in my application source code repo that has already gone through the CI process of testing that, and then packaging that software somehow. And then in this case, that would be like creating a new image and tagging that image as 020. We assume all of that has already happened as a part of our CI process. Now we're updating the GitOps repo, the declarative desired state, to say, go and deploy that new image tag into the Kubernetes cluster. So we'll make the change in Git, and then we'll see what that looks like in Argo CD after that. So we're going to do update 010 in guestbook values.yaml to 020, and then commit and push that to the main branch. And so by doing so, I have updated the declarative desired state, that first principle of GitOps. That desired state now represents running guestbook 020 in the cluster. And if we go back to Argo CD here, and you'll see that it has already detected that it's out of sync with Git. If you're following along on your end and it doesn't already show that, you can click refresh here, and that will trigger Argo CD to go look if anything has changed in Git. Normally this happens on like a 3-minute reconciliation loop. You could also implement a webhook in a longer term environment to speed up that cycle and automatically and I'd say instantly refresh the application as commits come in. So let's look at what's different. We can tell based on the visualization of the resources here that the guestbook deployment is out of sync. But if we want to see specifically why it's out of sync, we should go to the click app diff in the top here. And if you've got compact diff and inline diff already clicked, you'll see a very concise explanation of what exactly is going to change with the resources managed by this application. You can see that the only thing different is that for the guestbook deployment, it's going to change the container image from guestbook 010 to guestbook 020. So it really simplifies, like we made a change in a Helm chart, and that doesn't tell us precisely what is going to change in the manifests that are managed by the application using that Helm chart. So in Argo CD here, it's visualized for us to say this resource is going to change, and this specifically about that resource is going to change. So now that we know what's going to change, we can go and we can sync these changes manually into the cluster. So I'll click sync and then synchronize. And that goes, and as it should, it creates a new replica set for the new image tag, creates a new pod, spins down the old pod on the old replica set. And so that's an example of what it would be like for an application developer to go and work with deploying their application to Kubernetes using GitOps and Argo CD, instead of them running, Helm upgrade guestbook locally from their machine and having to have access to the cluster and having to have access to create all of these resources. And there's no tracking of the state of the cluster or why things changed. They can simply go make a commit to the GitOps repo and say, this is what I want to change, and this is why I want to change that about the desired state. And in this case, that would look simply like a commit like this that says, I want to bump the tag for this application to this new tag version. That could go through a pull request, get approved, and then go and deploy it into the cluster once it's committed into the GitOps repo and somebody clicks sync in Argo CD. There's a question in the Q&A here. Is there a way to update the Helm tag automatically after the CI process? Yes, there are plenty of options for how to do that. A lot of it depends directly on your organization's structure for how you're managing your configuration repo. But you could have it as part of your CI process to go and, instead of, like, if your CI process currently is to go and run Helm upgrade apply, or to go and do kubectl apply to your Kubernetes cluster, you could update that CI process to go and update that tag value in the GitHub repo, in the environment configuration repo, and then have Argo CD do the pulling from that repo into the cluster. There's also other tooling like the Argo CD image updater that, as new tags are updated in a container registry, it could update the application manifest to say, use this new image tag, and it can even go all the way to writing that back into Git for you. There are some good options there. Daniel should be able to link to the advanced GitOps workshop where we cover that topic a bit more, but it's a bit out of scope for the introductory run that we're running right now. So going back on track for a moment, we've demonstrated what it's like to change an application manually. Now let's go look at how we can automatically sync and even self-heal the application. So from Argo CD here, we'll go to, you're on the guestbook application. We click app details, and then under sync policy, we'll enable auto sync. And then we'll also, under sync policy, click enable for self-heal. And so what we've done is we've gone and updated the sync policy for this application to, if there's a change detected in Git, automatically go and do that reconciliation. Don't wait for us to click the sync button. Go do it as soon as you notice that the application is out of sync, as soon as Argo CD notices it's out of sync. And then we've also enabled self-healing. So if something changes in the live state that it deviates from the desired state in Git, go and automatically update that yourself. Or go and automatically update it Argo CD. So with that enabled, we'll demonstrate this auto sync functionality. So the same way we did an image tag update before, going back to the GitHub repo here, we're going to update the replica count from 1 to 2, and then I'll go and I'll commit that to the main branch. So we're saying for the guestbook application, which is currently running 1 pod per replica set, we want to now run 2 replicas. So we've set the replica count in the values.yaml for the guestbook Helm chart to 2, and I'll commit and push that to the main branch. And if I go back to Argo CD here, it'll either wait the 3 minutes here for the reconciliation loop, or if I simply click refresh, it'll go and check Git to see if there's any difference. And before, I would have had to go and click sync. Instead, there, it happened automatically and right away. So you can see that we're now running 2 pods, 2 replicas here for this. So that's the automated sync portion of it. So as changes are introduced into Git, Argo CD will go and automatically recognize it and make those changes. For demonstration here, let's see what happens if I were to go and delete the guestbook deployment altogether. So think of this as a demonstration of you're transitioning to GitOps. People still have access to Kubernetes to make changes or whatever, and an operator goes and accidentally deletes the guestbook deployment as a part of the a release or something to that effect. With self-heal enabled for the sync policy, when I delete this deployment resource, Argo CD is going to automatically recreate it, because the desired state in Git reflects that there should be a guestbook deployment. And then now that the live state has changed and gotten rid of that deployment, but the desired state is still requesting it, it's going to go and automatically update and self-heal that application to recreate that deployment based on that desired state. Which, when following all of the GitOps principles, the fourth one there being that all operations are done through the declarative desired state, this ensures that that desired state is always reflected into the live state of the cluster, meaning that you're essentially enforcing everybody to go through Git first, so that you know that that is the actual state of the cluster and not just a collection of configurations that may have drifted from the live state. So that's an example, and this is honestly quite fun to play with. The self-heal functionality. If you've got an example environment like this, you can just go and start deleting resources and seeing how quickly Argo CD can go and get back up. And if you've got a large application and you delete a bunch of things, it can be quite beautiful to watch the resource tree populate back out with all of the resources related to that. That's a bit of a tangent. So far, when we wanted to create this guestbook application for the first time, we went and we created new app, and we pasted the YAML file, and we told Argo CD imperatively, like through clicking in the UI, what to create. But the same way that this application is managing a service and a guestbook resource in Kubernetes, an application can also manage application resources, because they themselves are also Kubernetes resources. So the idea here is that in a bootstrapping scenario, you would create a top level application, and then that would deploy all of the other application manifests to the cluster that then point to your Helm charts and deploy your real resources into your clusters. So if we think of this application, it's pointed to the staging cluster. So it's saying the resources that I generate from this source should get deployed into the staging cluster and the staging namespace. We're going to create a new application that says create resources in the in-cluster destination, which is the Akuity platform, the Argo CD control plane. So in Argo CD, create more applications. And we'll go and we'll demonstrate that. So from Argo CD here, we'll click New App and Edit as YAML. And then going back to the GitHub repo here, from the app of apps file in the root of the repo, appofapps.yaml, copy the contents of that file, and then bring that over to Argo CD here and paste that. And then let's walk through it. So the idea here is that from the apps path in our GitHub repo on the main target revision, the main repo, deploy the resources generated by this application from that apps path to the in-cluster destination, which is the Akuity platform, the platform hosting Argo CD. So essentially deploy the resources generated by this application into Argo CD. And if we look back at our Git repo here, we can see that in the apps folder are more application manifests. So we're telling this top level app of apps to point to the apps folder, which then deploys other application manifests. And then ultimately these manifests are what go and deploys resources to the staging cluster as defined in their destination. And Argo CD will visualize this for us once we go and we deploy this. So in Argo CD here, after pasting the contents of apps.yaml, we'll click Save and we'll click Create, just like we did for the guestbook application. And then that'll go and generate the resources that it expects to deploy from that apps folder, which we can see is the guestbook application and the portal application. And just looking back at our Git repo, that's this guestbook file and this portal file. And if we look at the app diff here, so you'll remember that we already have our guestbook application deployed to Argo CD here. That already exists. But now we've got this top level application that's going to go and manage the deployment of that into Argo CD. So if we look at the app diff here, we'll see that the manifest already exists for the guestbook application. But the only thing that Argo CD wants to change about that is adding this annotation that says that this resource is now managed by another application in Argo CD. This is more of honestly a technical aside on how Argo CD does tracking of resources. But the idea here is to demonstrate that you can have an app deploy another app into Argo CD and manage the lifecycle of deploying it. Instead of having somebody go and click and create that application, you can go manage it through Git, just like you would your guestbook Helm chart or a directory of any other Kubernetes manifest, because at the end of the day, it's ultimately all Kubernetes. And then in addition to that, it's going to create a whole new application called Portal, which is going to look at the portal Helm chart in our Git repo, just like the guestbook one does. So when I click sync here, and we go out to the main page here, we'll see that nothing ultimately changes with the guestbook application. It's the same resources that are deployed, because none of that is changing. Just how the application manifest gets into Argo CD is now changing. That's now managed by our application. And now it's created a new application card. So we didn't go and click new app to generate this application. That's generated by the applications application. So if we go and look, because the automated sync policy is disabled for the portal app, you'll see that it hasn't started syncing the resources into the cluster, but you can see that it wants to create a service and it wants to create a deployment when you look at the app diff for it. And then just like with the guestbook one, you can go and sync it manually, or for sake of demonstration here, under the sync policy, if you click enable auto sync, it'll go and automatically sync the proposed changes into the Kubernetes cluster. And then just like that, we've got our portal Helm chart deployed into our Kubernetes cluster, our staging cluster that we've deployed the Akuity agent into. And with that, that is ultimately the end of the practical component for this webinar. So as an overview, we created our GitOps repo from a template here, which describes the Helm charts and the application manifest to deploy with Argo CD. We, from the Akuity platform, created an Argo CD instance that is hosted for you, provisioned an agent, deployed that to a cluster, in my case, on my local laptop, but it could really be any Kubernetes cluster with internet access. And then we used Argo CD to take the manifest, the desired declarative state in our Git repo, and deploy it into Kubernetes. We did so imperatively by clicking through the UI for the guestbook application, but we also did so declaratively using the app of apps pattern, where we have this top level application manifest, which we look in app details here, this top level manifest that goes and generates more applications that are deployed into Argo CD. And then ultimately those generate the resources that get deployed into the cluster that was connected with the Akuity agent. And so from here, you've got a CD process that is centered around GitOps. Anytime you want to make a change to the desired state of a cluster, you would do so through Git, and then ultimately Argo CD that's running within the cluster would go and pull that change into it, instead of you having to go run Helm template or kubectl apply to push those changes into the cluster. I think this is a great opportunity to ask any questions. If there's anything people are interested in asking about based on what they've learned today, or questions that they have around Argo CD. We've got about 5 minutes left here, and then we'll close out at 2:30. I'll give it a sec if anybody does have any questions. As mentioned earlier, this tutorial, the practical component, is posted on our documentation, and I'm always looking for feedback on it. So if there's a topic about Argo CD that you think was kind of missed in this, that's crucial to your understanding of implementing GitOps and CD, let me know. Hit me up on the CNCF Slack or Twitter, or feel free to post it here before we close out. Because I'm always looking to improve this tutorial to provide a better introductory experience to people that want to implement GitOps and continuous delivery, but maybe are missing some of the fundamental parts of why do it, or maybe it's a practical thing about how do I do X with Argo CD, because likely if there's something that you want to do related to GitOps or continuous delivery, Argo CD can probably do it, or there's a way to make it work with Argo CD. It looks like we don't have any questions here from the chat. which is no worries. I'm hoping that that the people that followed along today came out of this with learning either something new about continuous delivery, or I know for me, it's just always great practice to stay familiar with Argo CD and the concepts around it. All right. Well, since we don't have any questions here, I think we'll close it out and end it now. As always, if you're interested in using Akuity and learning more about it, we're available to do tailored demos, and I'm always happy to talk more about Argo CD or GitOps or anything Kubernetes related, honestly, on the CNCF Slack. Thank you, everybody, for joining today. I hope to see you back here when we do our advanced version of this, where we go into some more complex topics, building on what we learned here today.